Good morning, students. Today we are going to start with vibration and shock. In the previous lecture, we have studied temperature. Here we are going to learn vibration and shock. It is important to see effect of vibrations and shock on the product. For example, mobile handset, if it is placed in a car deck, then there will be a continuous vibration and it should sustain to that vibration. If mobile handset by mistaken fails on the floor, then there will be a sudden shock to mobile and it may damage. That is what a shock is, or effect of shock is. Now let us understand a vibration. When an engineer design a product and test this product under high environmental conditions, vibration and shock may not come to our mind immediately. We look at cabling, wiring, temperature and other parameters. We don't even look at environmental effect on design of the electronic circuits. And vibration and shocks, it comes in our mind at the last. Vibration can be a major source of failure in many systems. Hence, it is important to learn vibration. Electronic devices are subject to wide vibration stresses in a wide spectrum of application, ranging from train, automobiles, aerospace systems to power stations and drilling equipments. These are few examples of vibrations. So, a deck system in the car is more susceptible to vibrations. So, it should make more vibration free system. Many electronic product fails due to vibrations. Let us understand what is effect of vibration. Figure 1.10.1 is vibration mode or harmonic frequency for circuit boards. So some precautions while designing the circuit, some precautions should be taken. Here in figure 1.10.1, figure is a PCB board which is clamped to a front panel. So it creates certain vibrations like this. If PCB board is designed one under another like a table drawers are clamped to one under another. We have to avoid such type of arrangement of PCB boards in a circuit or in a product. So some general guidelines are there for reducing vibration problems. Which are these guidelines? What are these guidelines? These guidelines are: avoid cantilevers and sliding joints. That means this one layer below another layer below third layer, such type of PCB should be avoided. That is, cantilever type of arrangement should be avoided. Then sliding joints also should be avoided. Okay. Then second, use strip brackets, Z-shaped and channel. So Z-shape or one between another should be used. One PCB like this, second PCB like this, and third PCB like this. So PCB should be in a Z shape. Then only there will be less vibration in the circuit. Firmly anchor large masses, transformer and batteries. So these are mass. So it should not be at the top, or it should not be at the vertical side of your product. It should be on the basement of your product. It should be on the basement of a PCB, or it should be on the basement of a circuit. Then next, add support to long flexible circuit board. There should be some support to long and flexible circuit board. Then clamp larger components. Larger components should be clamped from one place to another place. Use short component leads. Short component leads, avoid large component leads. Rather, use short component leads. Means if lead of the component is short, then it should be used. And if large components are there, it should not be placed on horizontal surface, it should be placed on vertical surface. In a good design, you will find that horizontal long components are placed on vertical sides of a circuit. Mechanically damp heavy or larger structure. Heavy structure or larger structure should be pressed mechanically, or it should be covered with the mechanical body. So this is what some general guidelines for vibrations. If it is a IC, then what you will do, if IC with long leads are there, it will be better than a short leads. Short lead package type of dual inline package IC is not very good. It creates or it damages, and hence IC with long leads can be soldered firmly on a PCB design. Then second portion of vibration and shock is shock. Vibration is a continuous small shocks, while single shock, when your mobile falls on the floor, it is a shock. So absorbing capacity of that circuit or that product is nothing but susceptibility to the shock. Shock tends to be less destructive than vibration, which often occurs in many applications. The guidelines for reducing damage from vibration also apply to shock. The same guideline that we have studied is applicable to shock. In special shock mounts can absorb or damp mechanical joints as shown in figure. So figure 1.10.2 is shock mounts, and it absorbs or damp mechanical system. Even shock mounting system should be there. See here, your circuit is at the center and it is surrounded by this shock mounting system, which will absorb a complete shock. This is another example of shock mounting system. This is equipment rack. This is also a shock mounting system, and at the center your circuit should be placed. It absorbs the shocks. If there is shock, then shock is absorbed by these mountings and it will not enter into the circuit. If there is a shock to this circuit, then this mounting will break or lose first and your circuit will remain safe inside it. The same type of shock absorbing system is given in an equipment rack. So this is a equipment rack. When shocks are there, it will be finally transferred to your system. First, initially it is absorbed by shock mounting system. Shock is basically for a shorter duration and with a high magnitude. So it is of a shorter duration and of a higher magnitude. There are some minutes important for shock absorbing system. So we have to design a system in such a way that it will accept that shock for a certain time period. There may be a spring mass damper used in a shock absorbing system. Okay, so this is what a shock absorbing system and vibration and shocks. We will learn next part in the next lecture. Thank you.